All right, guys, sorry about that. All right. Let me share my screen. All right. So if you're in a waiting room, let me put you in. Okay, I lost few people. Looks like a few people is not here yet. So if you see it, just join again. I lost 3 students, but I don't know who just didn't show up because I was talking and then we, cut off. Oh, there you are. Okay. All right, so I will go ahead and continue. If you cannot get in, tell your colleague to notify me so I can admit you. If you're in a waiting room, I can see you, but if you're not in the waiting room, I cannot see you. So just go back and join that same meeting number. Okay, now. Okay, can you tell Brianna to just come back and join? Because she just texted me. I cannot put her in until she just come back and join. All right, so let's just go and continue this. This is a very, so look at this one. What they're saying is, if you're serious, you have the series, okay? Then I'm gonna put absolute value. Okay. If this one converges, then I don't have to worry about this one. This one just automatically converges. If the absolute value converges, then without the absolute value, it has to converge. That's what they said in this convergence theorem. So now let's look at that. So this one, this series, this is the one we just did it, right? This series is converges. We figured this one out, right? Because when you do limit test, it gives you 0, and then A1 is bigger than what? A2, those two conditions met. So by alternating series to get this to be correct, this to be a this series to be a convergence series. But let's look at this one. What happened if I put the absolute value on this? You get what then? The sign doesn't matter anymore. So you get 1 over n. What happened to this series? That series is what? Diverges. It's a harmonic series. The P is what? P is equal to 1. So which means it's not greater than equal to 1. So it doesn't converges, it diverges. We know this harmonic series diverges. So as you can see, this. Okay, as you can see, the absolute value of this, when you put the absolute value around this, okay, you get a just regular harmonic series, you get divergence. So in this case, this series is a conditional, okay, not absolute, but it's a conditional convergence. So sometimes you will have a infinite series, it converges, but it's not converges absolutely, which means if I put the absolute value, this become diverges. Or if I take the absolute value out, so without the absolute value, it converges. But if I put the absolute value on this, which that means everything become a positive, then in that case, it diverges. So some series converges absolutely, but some series only converges conditionally. So again, look at this. This is important right here. It is only saying this if the absolute value of this infinite series converges, then I know automatically without the absolute value converges. But not opposite way is not true. Just because this converges does not mean the absolute value will be converges. So the opposite way is not true. Only going from here to here is true. So anybody have questions about absolute convergence and a conditional convergence? Does anybody have a question?
Go over the conditional one again.
Conditional one means you may have the infinite series that may be converges. But if I put the absolute value, it may not converges. That case not converges. So this is a good example. Look at this example right here, the one they give you. You know this one, this converges. Why? It converges because we learned that alternating series converges if the limit of that series goes to what? 0. And then first term is bigger than what? Second term. Then by the definition, by the theorem of alternating series, that it converges. So without the absolute value, I know this will converges. But just look at this one. If I put the absolute value on this, okay, what happened? I don't get any negatives. Everything is positive now. Okay, so this really is same as 1 over n, just the 1 over n. But you know 1 over n diverges. It's a harmonic series. So as you can see, without the absolute value, it converges. But with absolute value, it didn't converge. It diverges. That's this kind of infinite series, we call it conditional convergence, because it only converges without the absolute value. Do you see the difference now? Absolute value means absolute convergence means the series converges with the absolute value and without the absolute value. That's absolute convergence. But if it only converges without the absolute value, we call it conditional convergence.
Cut the radio on.
Okay, is everybody with me? Is there any questions about conditional convergence and an absolute convergence? Well, let's look at the next problem. It's just some examples, okay? Example 6, absolute and absolute convergence and conditional convergence. Determine whether each of the series is convergent or divergent. If this is convergent, let's see whether this is absolutely converges or conditionally converges. All right. So you get to talk about absolute and conditional convergence if it converges. If it does not converges, you don't even have to worry about absolute what conditional. If the series diverges, then you don't have to worry about absolute and conditional ones. For this case, look at this problem. I need to figure out whether this will converges or diverges. Well, it is alternating because I see positive, negative, so it's alternating. So let's do the alternating test. So I'm gonna do that, then it's n factorial over 2n, right? So what happens if I plug it in? Does it give you what? Does it approach to 0? I'm asking you. Remember the divergence test? The nth term divergence test says if that's 9.3, okay? That's the one that we did. So this term does not converge to 0. All right? Most likely convergent to what? Some number, because you got an n factorial divided by 2n. So if you plug it in n as what? Infinity over infinity, all right? So definitely does not go to 0. It goes to some number, more like a 1, I guess, okay? So since the limit of this one is not equal to 0, then by the nth term divergence test, you can say this diverges. So I don't even have to worry about absolute or conditional convergence. Now let's look at the next one. So for next one, we're looking at this. Yes, it's negative, positive, negative, positive. So this is definitely alternating series. And can I rewrite this problem as n to the 1/2? All right. I did this so you can see this is your P. All right. So since it's since it's alternating series, I need to do alternating series test. So I'm gonna take a limit, n goes to infinity, 1 over n, which gives me 0. So first condition met. The second condition says A1 has to be bigger than A2. So A1 is, all right, so I said A1 bigger than A2, I really means you need to compare the positive with the positive. So I need to really compare with A1 with A3. Okay. So let me erase this part. So very first term is just equal to -1. What's this one equal to? -1 over square root of 2. This is negative square root of 3. Okay. So looking at this, actually, if it starts with 1, what happened to your series? It is getting smaller. I know that, but you cannot say an sub 1 is less than an, because this is definitely what? Smaller number. This is just smaller than this one. -1. -1 is smaller than what? -1 over square root of 2. I mean the positive square root of 2. So looking at this, I would like to say it's not it doesn't converges, but it doesn't make sense. I guess I have to say, if you put the absolute value, if I put the absolute value, okay, to me, telling the truth, the example they gave me for the number 2, the part 2 doesn't make sense to me. Okay, let me tell you why. Because the theorem says, a sub n plus 1 has to be less than or equal to a sub 1, right? From our problem has n starts with 1, and then it says -1 to the n. What was the problem they're trying to do? This. So when you're starting with 1, you get this number as the first one, which is -1. -1 is definitely smaller than positive of this number. So A1 is actually less than equal to A sub 2 this case. So I cannot really use this theorem, because this theorem says the A2 has to be less than A1. So this problem is not actually a good problem, all right? So don't worry about this one. Let's not do this problem, but just thinking about this one. This is what you need to think about it. This is absolutely converges. I mean, this conditionally converges. All right. So the example they gave you in your problem, this problem is not a really good problem. But I can give it to you, your homework problem. I got one more thing. Just bear with me, because I have to, because if I don't finish now, class, if I don't finish now, then I need to go over this one again after spring break, but since it's Friday. So can you stay with me another maybe 10 to 20 minutes so I can finish this and then go over a few homework problems? Is that okay with you guys?
Yes, ma'am.
Okay, is everybody okay? Can you say yes?
Yes, ma'am.
Okay.
Yes.
Thank you. Because I would like to finish it so I can go over a few homework problems with you. And then, we're going to have a spring break, so we're not going to have a class next week. So rearrangement of a series. Like sometimes you have to realize that when you rearrange problem, it's easier to solve, and then you can figure out whether that's going to be converges or diverges. All right, but we need to know about this. It's very important. It says a finite sum. The finite sum, like this, you finish right there, only have 1, 2, 3, 4, 5 terms. All right, can be rearranged without changing the value of a sum. So finite sum, you can rearrange your number whichever you want to, and then your value does not change. But the infinite series, it's not really true. You get a different answers. So you have this. So absolute convergent, which means absolutely converges. All right. Then the order does not matter. You can do any order, and the sum will be exactly the same. But if it's a conditionally converges, which means it only converges in this case, not this case, okay? Then if you rearrange, you get different number. So if it's absolutely converges, it acts like a finite series. But if it's a conditional convergent, you cannot change your order. If you change your order, your answer gets different number. Your sum gets different answers. This is a good example. So when you look at this series, the one that we've been looking at, when you do this word converges into, not converges, when you add all the sums, okay, you get a natural log 2. the summation of this, summation of this whole thing, this infinite series, will equal to natural log of 2. All right, it looks like this. 1, negative 1.5, 1/3, 1, negative 1/4, and it'll be positive 1/5, negative 1/6, okay, positive 1/7, dot, dot, dot. That added to be natural log of 2. But now let's look at that. You know this is only what? Conditionally convergent. Because if I put absolute value of this, which becomes same as 1 of n, which is what? Diverges. So this series conditionally converges. So if I rearrange this series, like this is your, I'm gonna write down a few terms, like this is what, how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We wrote down 11 terms. So we have 1, negative 1, negative 1/2, negative 1/4, 1/3, negative 1/6. So did you see we rearrange this number? Okay, let's look at it. If you don't rearrange, this is what you have. I'm gonna write down 11th term. You have a 1, negative 1/2, plus 1/3, 1/4, 1/5, 1/6, 1/7, 1, 2, 3, 4, 5, 6, 7, 1/8, 1/9, 1/10, 1/11, so on and so on. All right, but this is where you're supposed to write it, okay? But if I rearrange this, which means I'm gonna put 1 and negative 1/2, and then I'm gonna put this over here, and 1/3 over there. I'm gonna rearrange my series, okay? And then put 1/8 over here. Rearrange the series. Guess what happened now? When you rearrange your series, so 1 and negative 1/2 give you what? This. I'm gonna combine this together, which gives you what? That. Rearrange this, which gives you what? This. All right, so now I have 1/2, 1/4, 1/6, 1/8, 1/10, 1/12, like that. Okay, now I want to factor out by half. I'm gonna factor out by half. All right, so this become 1. This become this, negative 1/2. That become negative 1/3. So, but this is same as, this series is same as negative 1 to the n plus 1 over n. But you know what this equal to? It sums as natural log of 2. So when you rearrange your problem, you just get this, which means half of your regular series. You see what happened just now? Does everybody understand what happened? By rearranging your series, you get different sum than you're supposed to be. Does it make sense to you? Are you following me?
Yes, ma'am.
It's
Okay.
slightly confusing, but I mean, it's just a lot.
Okay, what they're saying is, okay, this is what you have to learn. The takeaway from this slide is, if it's a conditional series, do not rearrange, because you get a wrong answer. Your answer can be different than what it's supposed to be. The true answer for this series, okay, this alternating series is equal to natural log over 2. But when you rearrange like this, all right, you're putting a 1 and negative 1/2 together, 3 and negative 1/6 together, 1/5 and negative 1/10 together, you get a half terms. right there, right? So you're creating a different series by rearranging your sums, your terms. So you end up having this, which is only half of your regular series sum. So that's what takeaway is. If it's a conditional convergence, do not rearrange your terms because you get wrong answers. You get different sum than you're supposed to be. That's what that is. All right. So let's look at the homework problem because I want to make sure that I have time to go over some homework problem. All right, 9.5. Excuse me. All right, so 9.5. Let's look at the very first homework. So looking at this, I need to know whether this converges or diverges. So let's just write down a few terms. You get negative, it starts with -1. So it starts with the positive. Does everybody see it? So -1 and +1, the n starts with the positive, so which is 2. So it starts with a +1. So I'm gonna say I will have 1 over 1 plus 4. Next one will be 1 over 2 plus 4. Next one will be 3 plus 4, so on, so on, so on, so forth. So you have a 1/5 minus 1/6 plus 1/7 minus 1/8, dot, dot, dot. So they are alternating series. All right, now then we can alternating series test. So let's do the test. Limit n goes to infinity over 1 over n plus 4, that opposed to what? 0. So first condition met. What's the second condition says? Second condition says make sure the first term is larger than what? Second term, larger than or equal to second term. Let's look at that. So 1/5 and 1/6, which one is bigger? That one, right? Because a smaller denominator gives you a larger number. So this is larger. So since by that alternating series test, I can say this converges. Okay, is everybody with me? Any question from number 1? All right, I can move on. You can do the same thing about this. So I want to look at the one. Okay, let's look at number 4. Number 4 maybe need to be confusing. So let's look at the number 4. Determine the convergence or divergence of a series. So I need to figure out what this is, converges or diverges. All right, since it's a sine, all right, remember sine graph looks like this. So that's a pi into pi. So any number between from here to here, you have a positive a's, okay, positive terms. From here to here, what happened? You will have a what? Negative a's. All right, so they're not alternating series, in other words. Are you with me? Alternating series means you're gonna have a positive, negative, positive, negative, positive, negative, like this. So this series right here is not alternating series. So we cannot do the alternating series test. So we need to do different test. Is everybody with me? So I'm not gonna do that. So we can talk about I'll definitely talk about maybe nth term test. That's 9.3 that we learned, nth term test. So by doing an nth term test, It says if I take limit n goes to infinity of sine 2n minus 1 pi over 2. I need to know what that goes to. Okay, if it does not goes to 0, then by nth term test, I can say it diverges. But now I need to figure out, okay, let's look at this one. Because it's alternating, I need to figure out what's the best way to bound this. So since you know sine graph looks like that, I can replace, okay, I can replace this with times 1, okay? Well, I don't have to put 1. I can just replace that, simply go to n plus 1, because this will be equal to what? Negative, start with the positive 1, negative 1, positive 1, negative 1, because this will be always bigger than this graph. Okay, this graph is 1, negative 1, 1, negative 1, 1, negative 1. That's what it looks like. So I'm going to replace this with this. Okay. All right, then I'm going to think about this. Okay, now just look at this graph, this sequence, which I will have 1 minus 1 plus 1 minus 1, dot, dot, dot. All right, so let's take limit of this graph. I mean, this series, excuse me. Let's take a limit of this series. N goes to infinity, negative 1 to the n plus 1. All right, this will goes to what? Just negative 1 to the infinity. What does it give you? Some, I would say, isn't it 1? It goes to 1, right? Well, it could be some number. It's some number. Okay, some number. Definitely not equal to 0. It does not approach the 0. It's always alternating between 1 and negative 1. So it's not goes to 0. It's either 1 or negative 1, not 0. So this is either 1 or negative 1, never 0. So in other words, because of that nth term test, nth term divergence test, since the series does not approach the 0, I can say this is diverges. Okay, are you following me? Are you with me right now? Or you lost? Yeah. Are you with me? Did you see why? The first thing I did is what? Looking at this problem, I'm not so sure what to do, so I bound it using a what? Negative 1 to the n plus 1. Then this, I know what to do. I can take a limit of that.
Dr. Harris.
Yes.
Well, okay, when we first started, did you say it was not alternating?
Yeah, it's not alternating. Why? Remember, alternating series means you gotta have a positive, negative right away, right? But this graph is not positive, negative right away. Just sine, if you see a sine or a cosine, just draw yourself a graph. Sine looks like this. So from here to here, 0 to pi is all positive number. So if I have a, say, a sub 1, which is sine 2 times 1 minus 1 pi over 2, which is same as sine pi over 2, which is equal to what? 1. But now let's look at the a sub 2. So a sub 1 is a positive number. look at the a sub 2. You get sine 2 times 2 minus 1 pi over 2. What do you get? Sine 3 pi over 2. Oh, this case, you do get negative number. Okay. So, oh, I see what you're asking. So why this case? Since looking at this, you get a pi over 2, negative pi over 2, and then you get this one, and positive pi over 2. Is that what it is? Let's look at that. I'm going to look at individual ones to make sure that we are getting what it's supposed to getting then. Because I didn't plug it in any numbers first time, but if you literally plug it in as this, plug it in 1 for first one, then I'm replacing this with a 1. Next one is 2. So 2 minus 4 minus 1, which is 3. So the 3 pi over 2. Yes, 3 pi over 2 is negative 1. Let's look at the a sub 3. Then we should be same thing again, isn't it? 2 times 3 minus 1 pi over 2. So which is sine 6 minus 5 pi over 2. So that would be actually here. You're right. In this case, it is what? Alternating series, isn't it? It is alternating series. Because if you look at this one, you get a positive 1/2. Next one is what? Negative 1/2. Next one is what? Positive 1/2. What's next one? Negative 1/2. Yes, it is alternating series. But now, does it go to 0 though? So this problem actually, I mean, you can do your problem using nth term, but you can also do alternating series because when I plug it in number as the 1, 2, 3 and all that, you end up with 1, negative 1, and then what? Positive 1. Excuse me, this is wrong, right? You get 1, negative 1, positive 1, negative 1, and positive 1. So if this is the same, then what can I say about this? I can say this problem is actually same as negative 1 to the what? N plus 1, which is, that's the problem we just did it. Using an nth term. Remember this one we just did? We didn't do it here, okay. So this is just like the one that we did it on your PowerPoint. So this, what happened to this term? That goes to what? Diverges. Because when you take a limit of this, it does not go to 0. It goes to either 1 or negative 1, always. Positive 1, negative 1. It does not approach to 0. So that's why this is also what? Diverges. This term diverges. Even though this is alternating series, this does not meet the limit test. Remember, to be alternating, the alternating series says there's 2 conditions you have to meet. The first one is you need to make sure that limit that goes to 0. But this limit does not go to 0. It goes to either 1 or negative 1. It's keep alternating between 2 numbers. They're exactly the same number. So it's either be 1 or negative 1, never 0. So because of the limit part does not meet, so this one is not a convergent. This is divergent.